Well, good evening. We were talking last week about angle relationships. We talked about complementary angles, supplementary angles. We talked about vertical angles and adjacent angles. Now today we're going to talk about when parallel lines are cut by a transversal. So make sure you have your composition book and your foldable out. So first you're saying, what do you mean by parallel lines cut by a transversal? Well, here we have our parallel lines. They are being cut by what is called a transversal. So this green line that I just drew is your transversal. And if I were you, I would draw a picture of this off to the side from your foldable so that you can label some things. Okay, now when you have parallel lines that are cut by a transversal, it creates 8 different angles. And we're going to learn the relationship between all of these angles. If we were to talk about angle 1 and angle 2, based on what we learned last week, angle 1 and angle 2 are on a straight line, so they are supplementary. Okay, we also learned about adjacent angles. We could say that angle 1 and angle 2, as well as angle 2 and angle 4, those are all adjacent. That just means that they are right next to each other. They share a ray with each other. Okay, that's what adjacent angles are. Then let's review the last type of angle that we talked about last week, and that is vertical angles. Angle 6 and angle 7. Then we have angle 5 and angle 8. We have angle 1 and angle 4. And then we have angle 2 and angle 3 are all what are called vertical angles. Remember that supplementary angles have a total of 180 degrees. So angle 1 plus angle 2 would equal 180 degrees. Vertical angles are congruent. So if I told you that angle 2 had a measure of 115 degrees, then you would know that angle 3 also equals 115 degrees because vertical angles are congruent. Alright, now let's get started with our foldable for today. So when we are talking about parallel lines that are being cut by a transversal, we have to first talk about what are called same side interior angles. Okay, interior means that they come in between the two parallel lines. This is the interior. Okay, anything in between the parallel lines is interior. And they are on the same side of the transversal. Okay, that's what same side interior angles are. They are in between the parallel lines and on the same side of the transversal. So another pair of interior angles would be here and here. If you want to use a different color to indicate that, that's fine, because these will be one type of thing here, and then these over here that were already done are another pair of interior angles that are on the same side of the transversal. Alright? Now let's do an example. If we have this right here, and we know that this angle is 3x and this angle is 60 degrees. Same side interior angles are supplementary. That means that they equal to 180 degrees. So, if we want to find out what the measure of 3x is, we know that the two together equal 180. So we would say 3x plus 60 equals 180 because the two angles together equal 180. Now all we have to do is solve for x. So we do an equation. We first subtract 60 from both sides. So now we have 3x equals 120. Now we divide both sides by 3, and so x equals 40. That is not what this angle 3x equals. That's not what this equals. We now have to say, okay, so 3 times 40 equals 120. So this angle right here is 120 degrees. Alrighty? Alright. Some of you may be saying, yeah, but that looks like an acute angle. Remember, in geometry, we never go by looks. We always have to prove everything mathematically. Okay? So mathematically, this says that this angle is 120 degrees. Now let's talk about corresponding angles. Corresponding angles have corresponding positions relative to the parallel lines. So, this black dot up here, and then this black dot down here. They are both on the right side of the transversal and just above the parallel lines. Okay? So those are called corresponding angles. Let's talk about some more corresponding angles. This angle right here would correspond with this angle right here. You say, okay, that makes sense. Well, let's talk about some more. This angle right here would correspond with this angle right here. And last but not least, this angle right here corresponds with this angle right here. And again, if you use different colors, it will help you understand your notes better. So, another important thing that we need to know about corresponding angles is that they are congruent. So, this angle up here corresponds with this angle right here. And we know that they are equal to each other. That's what congruent means. So what we do is we set them equal to each other. So in order to solve for what this angle is equals, well, let me just erase instead of, here we go. So that we know what this angle equals, we have to set them up equal to each other. So we would say 63 equals 2x plus 1. So now we have to solve for x. So our first step is subtract 1 from both sides. Now we have 62 equals 2x. To find out what x is, we divide both sides by 2. So now we have x equals 31. Now, in order for us to find out what the measure of 2x plus 1 is, we would say 2 times 31 plus 1. So, 2 times 31 would give us 62, plus 1 gives us 63. So that is showing us that these are congruent to each other. On our next flap, we have what are called alternate interior angles. Again, interior means that they are in between the parallel lines. Alternate means that they are on opposite sides of the transversal. So they are not adjacent to each other. They are in between the parallel lines, and they are on opposite sides of the transversal. So two of them are already in place for you. And then we have these two that would also be considered alternate interior angles. Alternate interior angles are also congruent. That means that we set them up equal to each other. So here we would say 3x equals 139. To get x by itself, we would divide by 3. When we divide 139 by 3, we end up with x equals 46 and 1/3. If we take 46 and 1/3 and we multiply it by 3, in other words, we plug in 46 and 1/3 for x. Okay? We change 46 and 1/3 to an improper fraction. So we say 46 times 3, which is 138, and 138 plus 1 would give us 139. So we're taking 139 over 3 times 3 over 1. Well, our 3's can cross-reduce. 3 goes into both of them, so we get 139 over 1, which then equals 139. Alright, so next we're learning about alternate exterior angles. Exterior means that they are above or below the parallel lines. So up here and down here. This is exterior. And they are not adjacent to each other, and they lie on opposite sides of the transversal. So another pair of alternate exterior angles would be this angle and this angle. They are below or above the parallel lines, and they are on opposite sides of the transversal. And just like our alternate interior angles, our alternate exterior angles are also congruent to each other. So that means, again, we set them up equal to each other. And you say, well, this is easy. Why are you setting them up equal to each other? Why don't you just say that 2x plus 1 equals 101 degrees? I'm showing you how to do this because when we do some problems on our assignments, it's not going to be that you know that one of the angles is 101 degrees. They may have another equation for the angle that is 101 degrees. Okay? So what we have to do here is we have to say 2x plus 1 equals 101. Solve for x. We subtract 1 from both sides. So we have 2x equals 100. Now we divide by 2 on both sides. X equals 50. So now if we go over here, we're going to say 2 times 50 plus 1. That's 100 plus 1, which gives us our 101. Okay? You'll see how all of this ties in together when we meet tomorrow. Something to think about. I want you to think about something in real life that looks like two parallel lines intersected by a transversal. Okay? So think about that. What in real life do you see almost every day. You see it when you come to school even, where you would have two parallel lines cut by a transversal. So, when you come to class, if you find something, when I ask the question, I want you to tell me what you have come up with in real life that is two parallel lines cut by a transversal. So, have a good evening, and we'll see you in class.